Hello and welcome. In this video, I'd like to share with you the milestones for the sub-projects of the electrostatic sandbox project. So as I have demonstrated before in the previous videos, the electrostatic sandbox SDK is subdivided into sub-projects according to the paradigm of the hardware abstraction layer. Right? So we have a hardware infrastructure, a software and networking infrastructure, and a simulation infrastructure. Right? So all these infrastructures actually lay down the basic process. ElectroIO for the hardware infrastructure, ElectroNetSoft for the software and networking infrastructure, and ElectroStem for the simulation infrastructure. So in this video, I'd like to present, and we will actually create and build the milestones for these projects on GitHub. Right? So let's get started. And by the end of this video, it's contemplated that you will learn more about the electrostatic sandbox SDK internals, what will be present and what might not be present. And if you want to contribute, you will actually get the tasks for contribution. The only thing that will be missing is the contribution guidelines, right? So let's start now. I'm getting this node, and let's get started. All right. So perfectly safe. When we open this, run the script. Just need to make you focus, stand still, and not move. Okay, we are back. The stream is now working fine. The audio is working and the stream is working fine. We can get it as low as possible. Alright. So the image is still not present here. So I have to select it back, and it's now online. Alright. So let's get over to the electrostatic sandbox SDK. And as you see here, let's get to the issues. Right? And let's see the milestones. We have a milestone for the SDK release. but let's ignore this for now and create a new milestone for the ElectroIO project. So this, or we should name it as project ElectroIO. So this is an ElectroIO project, and it's contemplated by the date. It's actually, no, sure. Yes, it is contemplated. The ElectroIO is contemplated by the 24 to 2025. So I'm going to give it a milestone of the 2026, the proof of concept period. So this will take a milestone of the 2026. Right, we could change this to 2026 and take, for example, January as an example. For now, that will be the due date. Right, January. Okay, anyway, the date doesn't matter. We can do this as January. So this is the description. Description. This is the hardware. This is the hardware infrastructure. The hardware infrastructure. Binaries for the electrostatic sandbox SDK. By the end of 2025, it should house basic interfaces for the hardware infrastructure, and only concrete code for the AVR microcontroller. So that's the basic stuff. Let's check the video. It's working fine. So that's the basic stuff. That we have now. This is the hardware infrastructure binaries for the electrostatic sandbox SDK, and by the end of 2025, it should house the basic interfaces for the electrostatic sandbox. In addition to only the concrete code for the AVR microcontrollers. Alright? So this is our first project. Let's create this milestone, and now let's create others. We have the project. So this actually, let me just clarify something. This actually will be the ElectroMIO and not ElectroIO, because we have decomposed the ElectroIO into ElectroMIO and ElectroKIO. So this will be a better name, of course. So project ElectroKIO. That's ElectroKIO. It will be also at 2026, and the months will be, for example, January, and the day could be 15, for example, or 1. It doesn't matter. The description. This is the Linux, the GNU Linux kernel user space implementation and interfaces for the hardware infrastructure. Right? By the by the end of 2025, it should be contemplated to have the basic communication protocol implemented. That basically entails the actual Wi-Fi IEEE for IEEE 802 and the parallel IEEE 1284 and the actual Ethernet. I can't remember its specification, and the PCI Express. That's not an IEEE standardization. Alright, so those are the basics and the RS-232 standards. That's the basic stuff that we want to have. Alright, let me check the video quickly. Very good. Yes, fantastic. Alright. Let's create this milestone, and now we have the project MIO and KIO. Let's fill these with some issues so that people could contribute. So we have to base our issues on something. So mainly you will have something like the ABR microchip, maybe the ABR microchip 80 mega 32. That's cheap. We will download this. I guess it's already downloaded, but I don't know where for now, so we could open it online. Yes. This one is for the 8-bit micro. This one is the old, very old. Well, there is a new one. The microchip has a new actual. No, this is not for ElectroMIO. So by the end of 2025, we should have interfaces for that's generic interfaces, and not particularly for the 80 mega 32, but the actual code, the actual internalize the code, or the where the actual the actual infrastructure, the actual concrete code would be written only in AVR for now, which is the actual migration from the Chef AVR project, right? But there is a problem here. There is a problem here that there were a new we could use any one of these. We will not go over all the data sheet. Alright. So not go over all the data sheet. We just will use this to gain some knowledge of this. So the AVR CPU core, there is no anything to implement, but there is no anything to implement here. This whole discussion and explanation of the things that we have, but the implementation start from the I/O, start from the interrupters, maybe the system control. I think maybe the system control. I don't believe so, but no, this is not. This is all about the hardware itself. From here begins the actual software. All right. Then you write the software to manipulate hardware and things of that stuff. Okay, we can get this even lower So we better designate this. All right. So uh, let first let me first open an issue to migrate the Shift AVR. So if you would like to know to see the Shift AVR, you can just open the ElectroStat lab and right and open the electrostat lab, and you can find it here in Shift. Let's just type, or it's already linked here. This is a Shift AVR. So we only have like the UART, the universal asynchronous receiver transmitter, the analog digital converter, and GPIO implemented into these with their examples. So there will be an issue to migrate the Shift AVR to the main board. If you would like to take this issue and start working on it, I will be happy to. All right. So I will be happy to review this and integrate it into the project. And also, if you have insights, it's okay. So we will say that this is an ElectroMIO. Please, I'd like you to actually to notice how I write the actual milestones and these issues, these kind of issues, the structure I use to write these issues, because this is a part of the guidelines that you will use later when you actually contribute to the project. All right. So we will open an issue here that is Shift migration of the Shift AVR project to the electrostatic core. All right. So we'll mark this as good first issue. This is a good first issue, a part of the system design, and you should have one for the hardware. This is not a serial base, you should have one for the hardware here. This may also have some build script related stuff, so it's not hard, but you have to know some techniques of manipulating the CMake configurations and the bash, the bash that is already presented. So you should go over the build before trying to contribute to this actual issue. So you're trying to fix this issue. So I'm going to write now a description for the issue. In order to write a good description for the issue, I have to specify everything, right? But this is actually already specified, so you already know. So I'm just giving you the link here. So I will say that this issue, for example, it entails the migration of the project Shift AVR to the electrostatic core module without additional without additional APIs, right? Without additional API implementation. So we will defer the API implementation for other issues. So please, if you are going to work on this issue, let us make it straightforward. Do not actually add like optimizations, code optimizations, or code styling and so on and so forth. Let this be another pull request. Alright, so we just get this here, and then the electrostatic core, we can type it. We have to get the link to the electrostatic, where this implementation should go. So typically the electrostatic core by the end. And by the way, to manipulate this, you have to go over the. You don't have to go over CMake list, because it's already there. You give it here the toolchain headers and the actual toolage chain here. So the actual compiler collection here, right? So you give it the compiler collection. You just need a file like this. You just need a good file like this one. Inside the project documentation. No. Not this one. Let's compile all. Alright. You just need a good file like this. Alright? Good file like this. And you give it the actual GCC binary and the GBP binary. It's just, let's say, you can find these at the AVR tool chains, right? And then specify the folder that we wanted, and then the actual architecture. You want to output, you want to compile for 80 mega 32 or 32 8B or 16, for example. It depends on what you are trying to do. The current Shift AVR only supports 32 and 32 8B, but the interface actually can be expanded to support others, just some header functions, some header macros, right? So let us continue, because this we need to add this to the milestone, and then we add this to the ElectroMIO. Let's submit this issue, and now we have an active issue here. That's the issue. Drop this out for now. So this is the main issue now. The Shift AVR has the libUART and libGPIO and lib ADC already implemented. Alright? So we will just create issues for the others. The SPI, the two-wire interface, pulse width modulation, and the timers. And we have a reference to get this out. So let's see, the GPIO, maybe the GPIO here. So the general purpose input output, the timers, that would be another library. The actual SPI, the self-refer interface. The UART is already implemented. We won't get into the details of this, we just need the basics. A two-wire serial interface, the TWI here, and the analog comparator. What is the analog comparator? This should go into the ADC. The lib ADC. Anything missing, we will not approach it for now. So anything missing in the other libraries, we will not approach it for now. And we will try to approach these during examples, right? But the actual interface, we need to refactor the interface. So we should have like another issue. That the ticket for this issue is ElectroMIO / the title is ElectroMIO / lib GPIO. Alright? And we say that refactor lib GPIO to a generic architecture. A call to refactor the Shift AVR lib GPIO, the Shift AVR general purpose or the Shift AVR lib GPIO into an agnostic interface that supports. This agnostic interface should support all types, should support all the protocols. GPIO of other microcontrollers. Microcontrollers, for example, the PIC, the USB, and the ARM. Right? So the refactory into an agnostic interface that supports all the protocols. That supports GPIO protocols. GPIO supports GPIO infrastructure. That supports GPIO infrastructure of other microcontrollers. This is not. This is entailed as an enhancement, and it's a system design, and also it's a steel-related material. This should go to the ElectroMIO as well, and we should have for the labels. We should have another label for ElectroMIO, and this would be, I think, this color, maybe this color, ElectroMIO related material. Alright, and now we get that to the point. We have the libGPIO, the refactor. We need other issues like these for the rest of the ElectroMIO as well. So we need this issue, but not lib UART. Factor the lib UART to a generic architecture. We should have like the same description here, but let's get it for now. Enhancement and ElectroMIO and system design and a theory. That's the issue. Then what we need to add it to the ElectroMIO and submit this issue. Now this is added to the milestone of ElectroMIO. Let's go over this back here and add the rest of the ElectroMIO here. Get this copy. And then during this, I guess now we have the ElectroKIO, and we need to establish thing. It's a very similar issue, but we have to make sure that everything is agnostic as possible, because the good software is determined by its good abstraction. So if we have a good abstraction from the start, if anyone could implement the IEEE 1516 simulation infrastructure for a particular microcontroller, so even if he is the one who builds this actual device or the development code or anyway. So that's why I actually spend a lot of time on this. And by the way, I hope this video actually finds you if you are lost, if you are still lost, you find your way to contribute to the infrastructure or to the framework, right? So I hope you find this during this video, and I hope it's not an actual waste of time. because it might actually seem a waste of time, but this it's probably it's not a waste of time, because every second you spend on the project, you gain some knowledge about how this will go, the flow of the project, because the project is too large to get out, to give it out in a single video, so you have to wait a lot and watch a lot about this to become more familiar about the project, right? So this is the one for the ADC. So we have like the three things are now done: the libUART, the libADC, and libGPIO. Now we go over the unmaintained or the uncreated ones, and we will do the same issues there. And this actually finishes the video, because this will be the list for the ElectroMIO. So if you want to contribute to ElectroMIO, it's far simple. You see this is a filter, right? I could write here the ElectroMIO, for example. That will lead to this filter, right? This elegant filter here. So you will find this as a migration, and then the refactor, and then the refactor, and by definition the refactor cannot go before the migration is completed. So these are sequential issues. You should start with the migration first. If I have enough time to do this during the next week, I will finish this, and I might be able to create another video to let you know that I have just finished the migration, and you are welcome to start refactoring and tinkering with the ElectroMIO project, right? But for now, you should know that that's sequential, and I will not ever accept a refactor without a migration, because this makes sense. You need to have the project first before refactoring. I can't accept an empty interface without a concrete code, and I can't accept a concrete code without an interface. So you need to get it all at once and then migrate it. And also, you should know something, that this issue does not address the enhancements. So you shouldn't actually like merge the enhancement into the migration in a single pull request. This will be rejected. All right. So you have to do this in chunks. You have to be very specific to the tickets issued here. The ElectroMIO, you do only, if this actual issue is migration, then the BR should be only migration. It shouldn't be anything else. You shouldn't have this. It's good to have the enhancement in your code, in your BR, but not at this point, right? Not in the same BR as the migration. They should be separated, right? Each BR should target a specific issue, and only one issue for now. For later on, we can have like multiple issue targets. But for now, the project is at its start, and we don't want everything to go out of control, right? So I will see you in the next video. I will complete the other protocols there from this data sheet. Here you will find the protocols at the ASML or the microchip website, the data sheet for the RFMega 32, and I will go over the protocols and see if any protocol we will need to implement in the primer version that's contemplated in 2026, and then I will add those issues for these protocols and add them to the actual milestone of the ElectroMIO, right? So I see you in the next video. Hopefully we will go over the lib or the ElectroKIO libraries, and we will create an ElectroKIO milestones with some ElectroKIO issues. That will be the library that address the GNU Linux interfaces, the POSIX standard, or the IEEE 1003. This is the POSIX standard that is actually one of the good standards that most systems actually use for now, and even the Microsoft Windows has when the 132 APIs has a lot of like implementations. There are a lot of implementations on Windows using the POSIX interfaces and using the Win32 as the core APIs, right? So this will be the focus for the kernel. The problem is that our code will be more towards the GNU Linux itself and not the actual POSIX interfaces. So this might be a problem, but we will see when it comes. We will see the problem and how to deal with it. But for now, let's just keep things like simple as far as possible. So you guys could continue.